Welcome to Air Pollution Control Engineering. This is air pollution control in cement industries in India. India has undergone sudden surge of industrialization in the last few decades, which lead to the economic and the social development of India, a developing nation. Hence, the steel production and the power generation and the cement production is the most industry in India due to the decrease in the demand of cement construction industries. Major pollutant to air from the cement production are methane, fume, dust, nitrogen oxide, sulfur dioxide, carbon oxide and carbon dioxide, which are responsible for the global warming potential, which can harm the environment and can also harmful to human and the plant health through respiration. Dust flying from the cement production process are transported through the air and deposits in the area are close to the manufacturing plants and so away from the distant places. This include villages from the town, green area, recreation places, natural vegetation and the agricultural land. Cement industry is listed by the Indian Central Pollution Control Board as one of the 17th most pollutant industries in India. To combat degrading human health and mitigate against climate change by reducing GHG concentration in the atmosphere. This report will recommend an environmental friendly technology for air quality control in the cement industry, such as wet production of cement, replacing electronic filters with backhoe filters and precipitators due to comparatively high efficiencies. Indian cement industries. India is the second largest cement producing country after China. It plays a vital role in India's economy, providing employment to more than 1 million people directly and indirectly. It consists of a 209 large cement plants with the installed capacity of 387.3 million ton per annum. India is a highly populated and has high potential of infrastructure development because with the high investment from the foreign and the native investors. Availability of the limestone and the coal is also a reason for the boost of cement industries in India. Economic aspect. Indian industries plays a vital role for the economic development since 2008 to 2009. Cement industries occupies important places in India's economy as it have a strong linkage to other sectors such as construction, transportation, coal and power. Indian cement industries has its highest export to the Nepal. It accounts for about 49% to Sri Lanka, Bangladesh, Iraq, Egypt, Maldives and other countries to export. Indian cement industries is the oldest sector in India and is driven by the infrastructure development, construction and transportation. Social aspects. Indian cement industry provides job to 1 million people directly or indirectly. It has been a strong asset for infrastructure development in the society. It provides free drinking water, medical, electricity and the educational facilities to the people. Environmental impacts. Emission of CO2 is the most significant health and the safety issue regarding cement industries. It is one of the anthropogenic source of air pollution. Cement industry is considered as the most polluting industries in India. It has an adverse impact on the air, water and land, decreases in the productions of the and the growth rate of the crops we observed in India due to pollutant emitted. It also changes the chemical composition of soil. It is estimated 5% of the global CO2 emission in cement industries. Pollutant and it affect health. Pollutant from cement industries can be basically divided into two major parts. They are gaseous and the particulate pollutant. The gaseous emission include oxides of nitrogen, sulfur, carbon, volatile organic compounds and the hydrogen sulfide. Extraction of raw materials, fuel preparation, road cleaning and stocks are the source of particulate emission. Emission from transportation, fuel used, operating process and manufacturing itself are the other source of the emissions. Some of typical air pollutant and their health hazards are listed below. Sulfur oxide. Sulfur basically present in raw cement material. Emitted sulfur oxide reacts with water vapor and other chemicals in atmosphere in the presence of sunlight to form sulfuric acid. The acid formed can be washed away by the rain and snow, which is called as acid rain. It decreases agriculture productivity. Increase in the death of the plants can cause respiratory problems to the human beings. Carbon dioxide and the CO. Cement industries are the major source of the CO2 emissions. It is estimated 5% of total CO2 emissions is from the cement industries. Other source of the CO2 emissions are fuel type used, transportation and energy from the exhaustion of depots. CO2 is responsible for the global climatic change and the different respiratory sickness and the asthma on human being. CO causes health effect, decrease in oxygen delivery to the human body and causes effect of the cardiovascular and the central nervous system. Nitrogen oxide. Nitrogen oxide is formed due to the thermal oxidation which happens in the temperature range of 1200 to 1600 degrees Celsius. Family of nitrogen oxides include nitrogen dioxide, nitric oxides, nitrates and the nitrous oxides. Because of variety of family compounds, nitrogen oxide is responsible for the wide range of human and the environmental effects. The smoke created by the nitrogen oxide when breathed cause respiratory diseases. It creates difficulty in breathing, chronic lung diseases. It may ultimately result to the cancer diseases. Volatile organic compounds. Organic matter present in the raw material is the reason to produce VOC. Incomplete combustion of the process creates VOCs. VOC is the responsible for the ozone formation, contamination of soil and water. It causes retardation in plant growth. In human beings, it causes irritations on the respiratory tract, eyes and the skin, headache, damages in liver, nausea and damages to liver, kidney and the central nervous system. Particulate matter. Particulate matter are fine particles that can be suspended in air such as dust, root and liquid droplet. It reduces visibility and reduces the quality of air in the environment. It retards the growth of the plant. Particulate matter consists of the toxic metals such as chromium, lead, barium and the nickel. These compounds when inhaled through the respiratory tract causes various health effects to human beings. It can also risk of the cardiovascular and the respiratory diseases. It also causes the eye, skin, throat irritations. Particulate matter are the fine particles that can be suspended in air such as dust, soot and liquid droplets. These dust particles when washed by rain pollutes the water streams. It retards the growth of the plant. Particulate matter consists of toxic metals such as lead, chromium, thorium and the nickel. The compounds when inhaled through the respiratory drugs causes various health effects. It increases the risk of cardiovascular respiratory diseases. It causes eye, skin, and the throat irritation. Control technologies. Cement production is major contributor to economic growth in many countries. In cement production, there are many processes that takes place which emits various forms of pollutants. The main pollutant from the cement production are suspended particulate matter, carbon dioxide, nitrogen oxide, sulfur dioxide, and grey dust. The industries in 2007 is reported to have accounted for 5% of the greenhouse gas emission, which has affected the air quality. Cement production is energy intensive and the environmental degradation, health concerns as the result of the heavy emissions must be controlled. It is estimated that 8 tons of cement production produces 1 ton of carbon dioxide. There are many air pollution control devices APCDs used in cement industries to control emission of dust and other pollutants into the atmosphere. The particle size, the loading, flow rate, moisture content, and the temperature of the gases determines the type dust collectors to be used. For a particulate emission control, cyclones, multicyclones, fabric filters, bag filters, electronic precipitators, scrubbers, and the gravel bed filters are used. In this arrangement, the raw gas enters the filter through an inlet. Dust provides with guides to equality distribute the gas to the bag filters. This enables the downward gravitational force of the gas along the filter bags, forcing the dust into a hopper below. Electrostatic precipitator. The electrostatic precipitators are usually used for removing dust because it is efficient, simple in design, and operates at low pressure drop. The mechanism for removal dust is the electrostatic force. The device is made up of metal plates that are parallel and negatively charged wires. The raw gas moves through the channels between the plates at low velocity. The fine particles are ionized by the corona effect at the wires and moved along the electromagnetic to the earthed metal. The particles removed from the collector plates and discharged to the hopper below the device by wrapping at specific intervals. The efficiency is typically more than 99%, and due to the low pressure loss, the ESP is considered for de-dusting where particles as minutes 10 meter can be captured. With scrubbers, in this application, the polluted gases are brought into contact with the scrubbing liquid, which is sprayed into the stream of the gases to remove the pollutants. The scrubbers are designed to collect particulate matter and the gaseous pollutants. The wet scrubbers capture the dust particles with liquid droplets and the gaseous pollutants by observing them in liquid. The observation is double phase process in which the efficiency is dependent on the contact area between the liquid gas. Wet scrubbers are used in many instances and as support precipitation devices. The Venturi types are usually used for acid gases control and have good ability for separating particles by inertia. Backhouse. The backhouse filtration is one of the easiest and the effective methods of particulate matter control. The device is made of a fabric bags via which the airstream is directed. The particles are trapped in the fiber of the fabric bags as well as filter cake that is formed. The flow of air through the filter bag is either way, which enables the particles separated accumulate in the bag. The bag filters are cleaned when the manual method cleaning method. The emission of the acidic elements like sulfur dioxide, HCl, HF are removed from the system by the limestone as the base material. The cyclone. In the cyclones, the enters the cylindrical chamber under the high velocity, and the separation is by the higher impact inertia. The cyclones has low efficiency in particle. The removal and to improve the efficiency of cyclones are optimized. The low efficiency makes cyclones or rare devices for the fly ash removal. Nitrogen oxides, which result due to high temperature at which the combustion of the clinker takes place, are removed from the by using selective non-catalytic reduction. All recommended technology, although some manufacturers are replacing by the use of the electronic filters with baghouse filter, it is still recommended the electronic precipitator are used for the pollution control due to the comparatively high efficiencies. The wet scrubbers are also recommended for pollution control. The baghouses are also recommended for use in the pollution control due to mechanical cleaning of the filter and good SO2, HF and HCl. Conclusion: the economic and the social benefits of cement industries in India is huge. The structural developmental contribution cannot also be ignored. However, the impact on the environment due to degrading air quality, effect on the human health, and the quality of food production are equally necessitating immediate action arising from the pollutants associated with cement production using air control techniques, measuring and policies. The different type of air pollution control measures are employed in today India, ranging from the governmental policies and standardization processes or maintained in the report. Cement industries are also employing various technologies in compliance to government regulation to minimize emissions in the industries and global conventions and treaties to reduce GHG emission by 2030.